Hello and welcome to this video. In this video, we will solve more problems on theory of equations and polynomials. We have solved 5 questions in previous video. So we will try to solve more problems. Let's see how many we can go through. 6th question says that find the polynomial, this question. Find the polynomial of the lowest degree with integer quotients whose one of the zeros is square root of 5 plus square root of 2. So we know that irrational roots appear in conjugate pairs. So if one root is square root of 5 plus square root of 2, the other would be square root of 5 minus square root of 2. So fx would be, there should be brackets here. Fx would be x minus square root of plus square root of 2, and the other would be x minus square root of 5 plus square root of 2. So we have this equation, we multiply both. So we get x square plus 3 minus 2 square root of 5x. Now we take f2x as x square plus 3 minus 2 square root of 5x. Okay, we have f1x is this and f2x as its conjugate, x square plus 3 plus 2 square root of 5. The product would be x to the power 4 minus 14x square plus 9. So the trick is you get the first function using the roots and conjugate pair, and then get another conjugate function where you eliminate the square root of term. So fx eventually is of the form ax to the power 4 minus 14ax square plus 9a. That would be the final form of the fx. Question 7 says that if fx is a polynomial such that x into fx minus 1 is equal to x minus 4 fx for all x in R, find all such fx. So we are given the equation. So what we do is we put x is equal to 0. So when we put x is equal to 0, this becomes f of minus 1, and this becomes minus 4, and this becomes f of 0. So we have 0 is equal to minus f of 0. So f of 0 is 0. Now we put x is equal to minus 1. So that it becomes f of 0. So we left hand side will become f of 0 and right hand side will be minus 3 f of 1. So f of 1 would be also 0. Similarly, f2 would be 0, f3 would be 0. So now we don't put x is equal to 4 yet. So we assume that fx is equal to x into x minus 1 into x minus 2 into x minus 3 gx, where gx is some polynomial. Now we use the relation. So we have x into x minus 1 into x minus 2 into x minus 3 into x minus 4, g of x minus 1 is equal to x into x minus 1 into x minus 2 into x minus 3 into x minus 4 dx. So on left hand side, we use this relation, okay? And also on right hand side, we use the same relation. So from these two, we find that g of x minus 1 is equal to g of x, where x is in 0, 1, 2, 3, 4. So gx minus 1 is equal to gx for all x in real number set from the identity theorem. That means gx is periodic. That means gx is a constant function. So fx is cx into x minus 1 into x minus 2 into x minus 3. Next question is, let fx be a monic cubic equation such that f1 is equal to 1, f2 is equal to 2, f3 is equal to 3, then find f4. So because fx is monic coefficient of highest degree will be 1, we let gx is equal to fx minus x, where gx is also a cubic polynomial. Now we substitute g1 is equal to 0, g2 is equal to 0, and g3 is equal to 0. That means gx is x into x minus 1, gx would be x minus 1 into x minus 2 into x minus 3. So fx would be x minus 1 into x minus 2 into x minus 3 plus x. So f4 would be 10, and this should be plus. Next, question number 9 is find the fourth degree equation with rational coefficients, one of whose roots is square root of 3 plus square root of 7. This question is analogous to question number 6. So, first we find fx using the given root and its conjugate. So, we have the equation x square minus 4 into minus 2 square root of 3x. So we then construct f2x is equal to x square minus 4. This line is typing mistake actually, this shouldn't be there. And similarly, the first line of question 6 is wrong. So f2x is x square minus 4 minus 2 square root of 3x. And then we multiply it with its conjugate to get rid of the square root. So the quadratic polynomial which we get is x to the power 4 minus 20x squared plus 16 is equal to 0. Question number 10 says that find the equation of the lowest degree with rational coefficients which has 2 plus square root of 3 and 3 plus square root of 2 as two of its roots. So we are given two roots, and we know that irrational roots appear in conjugate pair. So we take two more conjugates, and then we have fx is equal to product of all those. And the product would be x to the power 4 minus 10x cubed plus 32x square minus 34x plus 7 is equal to 0. Question 11 says that find the polynomial equation of the lowest degree with rational coefficients whose one of the roots is square root to the power half and 3 into third root of 4. So as always, we have, there is some typing mistake. This should also be third power of 2. So we let y is equal to third root of 2. Then we have x is equal to y plus y 3y square, or y is equal to 3y plus 1. So we cube both sides, we get x cube is equal to y cube, 27 cube y cube. There is something wrong with this. I don't think this is correct. I will revisit this question. There is something wrong with this. Question number 11. The way it is solved is wrong. Anyway, I proceed with question number 12. Show that x minus 1 whole square is a factor of x to the power n minus nx plus n minus 1. So we have x to the power n minus nx plus n minus 1 is equal to x minus 1 into x to the power n minus 1 plus x to the power n minus 2 and so on up to 1 minus nx plus 1. So this becomes x minus 1 into x to the power n minus 1 minus 1 plus x to the power n minus 2 minus 1 and so on up to x minus 1, which is clearly a factor of x minus 1 whole square. Question 13 says that if a, b, c, d are all zeros of the polynomial 6x to the power 5, 5x to the power 4, 4x cubed plus 3x square plus 2x plus 1, find the value of 1 plus a into 1 plus b into 1 plus c into 1 plus d into 1 plus e. So because a, b, c, d are all zeros of the polynomial, so we have 6 into x minus a into x minus b into x minus c into x minus d into x minus e is equal to the equation. So we put x is equal to 1. If we put x is equal to 1 minus 6 into 1 plus a, 1 plus b, 1 plus c, 1 plus d, 1 plus c is equal to minus 3, which implies that 1 plus a into 1 plus b into 1 plus c into 1 plus d into 1 plus c is equal to half. So now, that's what we had to find. Yeah, that's what we had to find. Question 14 says that if 1, alpha 1, alpha 2, alpha, and so on up to alpha n minus 1 be the roots of the equation x to the power n minus 1, where n is in the set of natural numbers, n is greater than or equal to 2, show that n is equal to 1 minus alpha 1 into 1 minus alpha 2 and so on up to 1 minus alpha n minus 1. So because these are the roots of the equation, therefore we can write x minus 1 into x minus alpha 1 into x minus alpha 2 and so on is equal to x to the power n minus 1. Therefore, we can write that x minus alpha 1 into x minus alpha 2 and so on up to alpha n minus 1 is equal to x to the power n minus 1 plus x to the power n minus 2 and so on up to 1. Now we put x is equal to 1 like previous problem and we have the desired result. Question 15 says that if fx is equal to x to the power 4, there is a typing mistakes. So I think I will have to look at this to find out the equation. Anyway, this may be plus or minus, I will correct it. Ax cube plus bx square plus cx plus d is a polynomial such that f1 is equal to 10, f2 is equal to 20, f3 is equal to 20. Find the value of f12 plus f of minus 8 by 10. So we consider a function fx is gx is equal to fx minus 10x. Now g1, g2, g3 are 0. So here g1, g2, g3 are 0. So this is fx minus 10x. Okay. So in that case, g1, g2, g3 would be 0 because it is fx minus 10x. So x minus 1, x minus 2, x minus 3 would divide gx. Since fx has a degree of 4, so gx will also have a degree of 4. We let gx is equal to x minus t into x minus 1 into x minus 2 into x minus 3. So fx is 10x plus x minus t into x minus 1 into x minus 2 into x minus 3. So for x is equal to 12, x minus 1 into x minus 2 into x minus 3 is 990. And for x is equal to minus 8, x minus 1, x minus 2, x minus 3 is minus 990. So we have to find that 12 and minus 8. So in this equation, if we substitute those, and in this equation, if we substitute, we have 900, 990 and minus 990. So f12 and f of minus 8 by 10 would be 10 into 12 minus 8 plus 12 minus t into 990 plus minus 8 minus t into minus 990 by 10, which would be 1984. So these are the 10 problems we have studied, and one question we could not do, which was question number 11, and in question number 15 I have a typing mistake. That is, I will clarify whether this is plus or minus. Okay, so these two we will revisit again in the next video. I'm sorry for these typing mistakes. There are lots of typing mistakes in this because it has not been proofread. So we will revisit question 15 and question number 6. So I hope that you have understood this question number 15, how it has worked. And similarly for question number 6, we will revisit this. Okay. So thanks a lot for watching and have a nice day. So keep solving the problems and slowly you will become better. Thanks a lot again. See you in the next video.